All right, so we have, what is the speed of a spur gear with 30 teeth driven by a pinion gear with 10 teeth turning at 500 RPM? All right, so this problem is going to involve knowledge of the gear ratio and the speed ratio. So we need to know that these are inversely proportional. So with that being inversely proportional, that means whatever is going to be in the numerator of the the denominator of the gear ratio is going to be in the numerator of the speed ratio. Whatever's in the numerator of the speed ratio, the gear ratio is going to be in the denominator of the speed ratio. Basically, as one thing goes up, the other thing is going to go down. So in this case, we'll look at what's going up and what's going down. All right, so we have our spur gear. Normally, a spur gear versus a pinion gear, your spur gear is going to be your larger gear, if that is something that you want to know. All right, so this one has 30 teeth and it's being driven. So when it's saying it's being driven, it's not the one that's attached to the motor. This pinion gear is the one that's attached to the motor, and it's turning with 10 teeth, turning at 500 RPM. All right, so let's look at these couple examples that I have over here. So example 1 and example 2. So in this case, I'm saying the larger gear is the drive gear, and on this example number 2, I have the smaller gear is the drive gear, meaning this is the gear that's attached to the motor. This gear that's attached to the motor is driving the second gear. So we can change either the speed of it, the amount of torque we want to get out of it, whatever reason we want to attach the second gear to it. So right here, if I have a large gear turning a small gear, we can expect that the speed is going to go up. So the motor is what's determining how fast it's spinning, right? This drive gear is attached to the motor, and that motor is spinning with some RPM. Let's just say 10 RPM. So we can expect every time this goes around one time and it goes back to the start, this one, because the circumference is smaller, is going to go down around more than one time. Therefore, this one will have a faster RPM. But when we gain speed, what we're going to lose is torque. So this gear will have a lower torque, but it will have a higher speed. And then in example number 2, we have a smaller gear driving a larger gear. So every time this one, the one that's attached to the motor, every time it spins around, because the motor is what's determining the speed, every time this makes one rotation, this larger gear only makes a partial rotation. Therefore, the RPM is going to go down in this case. The size of the gear went up, the RPM went down, but the torque also increased. So what did we gain? We did gain torque on this example number 2. So what example do we have here? We have the driven gear is 30 teeth. So I'm going to use the ratio here, driven and drive. So I'm going to do 30, my driven, over my drive is 10. And therefore, what do we have? Example 1 or example 2? We have example 2. We have a smaller gear driving a larger gear. So we know that the RPM is 500 RPM for the smaller pinion gear. What should we expect the RPM of the larger gear to do? We should expect it to be slower than the drive gear. Okay, so whenever I'm setting this problem up, these two go together. So the drive is going to go over here with 500 RPM, and we're trying to solve for is going to be this speed. I'm just going to use X for the variable, and we're going to cross multiply. So we'd have 30X equals 10 times 500, which is 5,000. Finally, divide by 30, divide by 30. We're going to have X, which is the RPM, comes out to 166.6 repeating. So we'll just go ahead, for convenience sake, say 167 RPM. All right.